It's time to celebrate because you just finished your first data structure, and they're going to get more and more fun. But you see here that we've started to complete our mental model of data structures. I promised you that by the end of this course, this whole diagram is going to make sense. And we've finished a small part of it. The arrays. We talked about static and dynamic arrays. We talked about the big O complexity and how dynamic arrays can sometimes have O of n appends. Because, well, sometimes we have to double up or expand our memory. We also talked about how strings and questions regarding strings can be treated very similar to array questions, where you just convert them to an array and then join them back up and return a string answer that you need. And there's a few other points for arrays that we're going to talk about when we get into algorithms. But by now, you should take a look at the Big O cheat sheet and understand why the array data structure has these Big O numbers, and understand when an array is a good thing to use. One thing that you'll note when it comes to arrays, especially when we get to algorithms, is that they're really, really good at having sorted data. When it comes to sorting, arrays are awesome because they're in memory in sequential order, according to their index. Now, before I go on to the slide, you can pause the video, think about when you would want to use an array, when you wouldn't. Because in about 5 seconds, I'm going to show you the pros and cons. So pause the video and the answer to when you should use an array. Well, here it is. Arrays are great for fast lookups. That is just accessing information where you know which index you want to look up. It's really fast at push and pop. So adding things at the end of an array or taking things out at the end of the array. And of course, because it's ordered. Having something that is ordered and close to each other in memory makes it really fast. However, it has slow inserts and deletes because we have to shift arrays whenever it's not at the very end of the array. And then finally, if using static arrays, it's fixed size. That means sometimes you have to declare the memory ahead of time and how large of an array you want. But that can be avoided if we use some of the more modern languages that have dynamic arrays. Also, I just realized that this smiley face kind of looks like a crazy person, but this is meant to be good. This is good. This scary little icon, that's bad. Okay, I think we get it now. We're going to come back to arrays because a lot of other data structures we're going to talk about later on, like queues and stacks, are related to arrays. But for now, I want to get into other data structures because we still have a few to go through. I'll see you in the next one. Bye-bye.